Good morning, good afternoon, and good evening, everybody. Welcome back to yet another episode of our AIP podcast. My name is Cheng. I am CEO of SuperCharge Lab. And of course, your host on behalf of the AI Partnerships Corp. Today, we have a distinguished guest, Rami Abielmona. He is VP of Research and Engineering at Larus Technologies. Now, Larus Technologies is based in Ottawa, Ontario, and is an innovative company that develops embedded technology for mission critical C4ISR and security systems. Their flagship products have provided big data integration and automatic queuing and tasking of sensors and assets for more efficient and timely generation of actionable intelligence. Now, Larus Technologies' high level information fusion modules enable defense contractors and system integrators to provide customers with next generation systems that optimize decision making in the face of big data. Now, Larus has a proven track record in higher level JDL information fusion models and is at the forefront of innovation in the defense and security industries. Wow, what a mouthful. Huge warm welcome to you, Rami. What a pleasure to have you here today.
Thank you, Anne. It's great to be here.
Absolutely. So, Rami, tell me about you. How did you end up here? What's your background? What's your backstory? How did you get to Larus Technologies?
Yeah, thanks for that question. And so, yeah, you mentioned most of it there. My name is Rami Abielmona. I'm VP of Research and Engineering at Larus Technologies. So we're an AI machine learning data science company headquartered in Ottawa, Canada. And I came to Larus through my PhD. I did my PhD at the University of Ottawa, working on artificial intelligence. At the time, we couldn't actually call it AI. It was more computational intelligence that we flew under. And there's a society in the IEEE that's called the CIS Society. And at the time, this is early 2000s. AI actually wasn't really a good moniker to kind of use. Now it's kind of the other way around. If you don't say AI, you don't get published or you're not as well known. So yeah, I started working in the field back in the late 1999 and early 2000. Did my master's PhD in the field in artificial intelligence, both in terms of software and hardware. So I worked on kind of the early concepts that were kind of neural networks, genetic algorithms, fuzzy systems, but also implemented them in hardware on what are called FPGAs or field programmable gate arrays. Finished up my master's and PhD, and submitted my thesis on a Friday, and was at on my desk at Larus Technologies on a Monday in 2006. And yeah, started this journey with Larus Technologies where we were able to form kind of a research and development arm to the company, start producing some algorithms, some models, some products, patented a few along the way, and then commercialized the technology soon after. And here we are a few years later with a suite of products within our portfolio to answer a lot of different questions. Typically, the three most important questions that any client or any user wants to answer are, can you optimize, can you predict, and can you simulate? And you'll see, I guess, throughout this podcast, I'll focus a lot on these three questions: forecasting, optimization, and modeling and simulation. So that's kind of my backstory, and happy to be here again. Thanks, Anne.
Well, that is amazing. Let's dive right in. Tell us a little bit more about the embedded technology, how it works, how it revolutionizes, information accuracy and situational awareness. Let's dive right in.
Absolutely, yeah. Thanks. So again, Larus is a company, software company that specializes in artificial intelligence and machine learning. We also specialize in big data analytics and decision support systems. We're comprised of three core business areas. One that focuses on the solution space, so data fusion and analytical solutions. We've produced a few products in out of that department. We have a software kind of engineering consulting department that primarily focuses focuses in kind of C4ISR for public security and defense, as well as, in the past 5 years, we branched out to a few commercial applications in retail, supply chain, and e-commerce. And I'll come back to that point because, dual use technologies is very important these days. And our third kind of core business area is research and engineering. That's where we focus on kind of innovations or models or algorithms in advanced AI ML for, that are probably 2 years, 3 years ahead of their time, for big defense and what we call big defense and big retail. Those are the two kind of sectors that we operate in. So in terms of kind of our, what we bring to the table, we have a slew of products. One is called Total Insight, which is a predictive analytics, multi-sensor, multi-source decision support system. So this is a big data analytics engine that groups together multiple layers of data analytics, brings in, billions of messages per day, supports a variety of hard and soft data sources that can be seamlessly integrated and with other systems. It's very interoperable with other systems. That's kind of a real world, real time engine. So that's sub-second processing out. We have Total Perception. That's a system simulation engine that takes a different approach, solves kind of that optimization question using AI, ML, and modeling and simulation so that we can provide kind of enhanced queuing and tasking for ISR. I mean, I'm throwing a lot of acronyms your way, but ISR is intelligence, surveillance, and reconnaissance, so that we can provide kind of automated capabilities that are based on these novel AI, ML algorithms, tools, and capabilities. Total Vision is our kind of answer to computer vision. So it's an agile, adaptable AI, ML video analytics solution for public safety and infrastructure security industries. It leverages cutting edge advances in computer vision, AI, ML, so that we can do automated multi-level analysis of surveillance video, and transform that data into actionable intelligence for users. And then again, kind of an end-to-end solution called Total Foresight. You can see kind of the total family of products that we have there. It offers of an automated solution to improve any situational awareness, as well as plan, task, assign resources. So that kind of does the gamut, right? It does the forecasting. So if someone needs kind of time series forecasting, situational prediction, we can do that. Then we can do the optimization so that we can optimize responses that are generated by the tool automatically. They're simulated within the tool as well so that we can provide kind of performance metrics for the user. They're displayed seamlessly within a very GPU-enabled user interface. And of course, the modeling and simulation is in the back end so that we could perform and provide that to our overloaded decision makers that typically, the typical user for our suites are people that are just inundated with many tasks and they have a limited number of resources, time to make those decisions. So that's kind of where we come in.
That's amazing. Absolutely amazing. So, how does Larus Technology stay ahead of the curve in the ever changing defense and security industries? And also, what sets your technology apart from traditional low level data fusion solutions?
Yeah, that's an absolutely great question, and because I think everybody, on anyone listening to this podcast is probably facing similar problems or issues, in order to kind of stay ahead of the curve, especially in this digitally transformed world. And you would think that defense and security maybe are a bit older kind of industries. That's not the case anymore, right? I mentioned dual use technologies where algorithms could actually be deployed for commercial applications as well as security applications. So how do we kind of stay ahead of the curve? Well, we retain a pretty large competitive advantage because of our many capabilities that we have. We can mix data analytics with other data sources. So we bring in hard and soft data sources. So hard being like structured data sources, think like databases, sensor outputs, imagery, stuff like that, with a kind of unstructured data sources, think observational reports, social media reports, what we call kind of open source data. So we have the ability to kind of mix both of them to perform data exploitation, data fusion, situational assessment, and situational prediction upon that. We have a great team in house of AI ML experts and know-how that we built over the past 25 years there, that we can create any model, apply any algorithm. Really greatly separates us from the competition. We also have tremendous expertise in deploying these in the real world. So it's not something that is just meant for modeling and simulating and presenting it for a demo demo or a paper or whatnot. We actually have real world AI models that have been running in the field with our customers deployed for over 10 years now. And we deploy them on GPUs, CPUs for real time, real world data feed processing. We have expertise in ML ops, or what is called machine learning ops. It's kind of the cousin of DevOps, if you're familiar with that, so that you can actually deploy machine learning models in a production level environment, and a pipeline that allows you to go from input to output seamlessly in a very structured manner, and more importantly, in a repeatable manner. So, I think your question, could be answered in many different ways. One other way that I can think of answering it is thinking about those three questions again that I talked about: prediction, modeling and simulation, and optimization. And we've got great predictive capability. Namely, we've been working on this for over 20 years, as I mentioned. We're able to lower the chances of mispredictions. We use deep learning, obviously, so that we can provide that competitive advantage in both speed and accuracy. On the modeling and simulation side, we have great competitive advantages there because of our capability of mixing in source modeling along with some other AI ML driven techniques, such as contextual awareness, incomplete information handling. Like, if I only have 10 of the data fields out of the 15, how do I kind of complete the information for the missing ones? Perception management, process refinement, and in optimization, we've got great suites of products that are multi-objective optimization driven and that answer the question in real time. So I think between all those, that's kind of where we stay ahead of the curve.
That's amazing. So, final question. I want to ask about your future plans. What's on the horizon for you? How do you see the role of embedded technology evolving in the defense and security industries?
Yeah, that's a good question. From a Larus perspective, we exist to make better sense of the world. Really, we help our clients and our users to make sense of their world. We build the most advanced AI ML based products and services. We have three strategic goals for our firm. First and foremost, we want to cultivate kind of an environment where everyone actively contributes to the scientific, engineering, academic communities, and helps layers develop, as well as they develop as their own leaders in their respective fields. Number two, we develop a sustainable competitive advantage, as I mentioned, by leading and accelerating kind of the research into, as well as the development of, innovative predictive analytics and AI solutions. And three, we accelerate the growth through the identification, kind of prioritization, successful exploitation of opportunities in both domestic and foreign markets via strategic partnerships, relationship with other companies, and of course, end client engagement. I think the other part of your question is like, how do you see the role of embedded technology evolving in defense and security? Well, I do a lot of talks on this field, and some of my talks are kind of like lay down, the big brother versus big data kind of world, where it's like 1983 George Orwellian type future that we're getting into. But for this podcast, maybe I'll take a lighter approach to it, and I'll say something like, in general, when we talk about AI, machine learning, fusion, data analytics, there's different layers in the technical community that we refer to. Layer two is like situational assessment. So that's kind of like the basic understanding of who are the actors, what's happening in the environment, what's happening in the situation, what relationships do all these actors have at play within the situation at hand. So the embedded technology is already in there. Think predictive analytics, think descriptive analytics, think diagnostic analytics. Those are really well-known tools, that are out there, and that's a kind of a good solved problem. Next up is layer three, and I skipped over layer one and zero. Layer one and zero are very low-level fusion type things, so I'm not going to cover them. Layer three is more impact assessment. So that's like think of gaming, potential responses, and what happens when those responses occur upon that situation at hand. What's their impact? Can I measure that impact? Can I assess the impact? And more embedded technologies coming into that framework now. That's called prescriptive analytics. What should be my course of action, or COA? What's the impact of that course of action upon the environment or that situation at hand? And can I start recommending courses of actions? Layer four is more like process refinement. That's more like, mission planning. Can I change the rules of operations if I'm going into a firewall for a cyber type environment? Can I change, the firewall rules themselves automatically, or using kind of embedded technology in order to better manage my resources, manage my sensors, manage my tasking to attain some higher level objective? We're not there yet, right? So that's, Larus itself is pushing the envelope there, and we have models and solutions into that world. But as an industry, I would say we're not there yet. And then layer five, there's also layer six and seven. I'm not going to go through those because of time constraints today. But hit me up if you're ever interested in learning about those. Maybe I'll just leave it with layer five because that's a contentious, maybe one that I can mention. That's called user refinement. It's quite key. Really, that's where joint cognitive adaptation happens between the human and the machine, so that the human is obviously influencing the machine, but the machine could also influence the human. So the machine could start thinking and recommending that, hey, maybe the human should change the way they interact with this autonomous system, so that together the overall process effectiveness is dramatically increased. So you'll see this dual training of humans training machines and machines training humans soon.
That is, wow, a little bit of a dystopian future. But Rami, what a thrill to have spent so much time with you. And once again, to our listeners and those tuning in on all our social channels, thank you, thank you, thank you for your time. Thank you for tuning in. And once again, Rami, thanks for being on our show. This is Anne from SuperCharge Lab on behalf of the AIP podcast, signing off.
Thank you, Anne, and thank you, AIP.